Okay, this is a video about maintaining a collection of objects in a vector. In particular, it's storing these objects. It's actually storing pointers to these objects. So what we have is an array of pointers. Okay. Now the idea is we're going to start with this class inventory item. Now an inventory item object models something that you might be using in a program that was keeping track of inventory for some store, for some enterprise. For example, if you owned a store and you had to keep track of all the different items in your store, you'd probably have some sort of a program that would allow you to add items, investigate items, see what you have, what items you already have, and so forth. So inventory item models one item that you might have in your inventory. Since you're familiar already with classes, I'm just going to walk really quickly through the implementation of this class. It's already written. Inventory item is including string because one of the member variables is of type string. It's including IOStream because it will have a display method or a display function which will need to use the cout output stream. It's a very simple class. There are three private member variables: item name, item num, name, and price. Item num is as indicated in the comment, a serial number of the inventory item. Okay, because for every item you would want to keep track of its serial number or keep track of it using some unique identifier. The name, of course, is the name of the item. If it was a hardware store, it might be nail, hammer, screwdriver, saw, something like that. The name might include the vendor, whatever was stored in that variable. And the price is the price for one of the items, the price paid for one of the items. Of course, in a true application, we probably have many other member variables describing this particular type of object, but I'm just trying to keep this simple because the focus of the demonstration is the array of the vector of pointers. Okay, so in this class we have a number of public functions. We have two constructors: a default constructor, which will of course initialize all the member variables to some default value, and another constructor which takes a value of an argument, which will take an argument for each to be used to initialize each of the member variables. For each of the three member variables, there are set methods, there are get methods, okay, and there is a way to print out all the information on an object, the display item function. Okay, so this kind of stuff's pretty basic, and then we also might want to, at one point or another, be able to compare two objects of type inventory item, and this is not easily done unless we overload the equal operator and the not equal operator. Note that it doesn't make sense just to overload the equal operator without overloading the not equal operator, because they are two distinct operators and they both have to be defined for the class. Okay, so this is our class declaration, and this is in a .h file. Okay. Now in the .cpp file, we're going to include the .h file because, of course, that definition is needed up here. Basically, remember what a class definition is basically the declaration of your member variables and prototypes for all of your functions, and then your CPP file actually contains all the function definitions. So here, for each one of the functions that was mentioned in the declaration file, we have a full-out definition. Each function definition is preceded, as you'll remember, with the name of the class and the scope resolution operator, and that's so that C++ knows that this particular function is a member of that class. This function is a member of that class. This one's a member of that class, and so forth. And you probably remember from coding classes, if you forget this, and then you go to compile a class, you'll get errors when you try to access the member variables that you can only use from functions that are members of the class. Okay, so our two constructors pretty much do things your basic constructor does. This one initializes all the the 3 member variables to default values, kind of indicating that nothing has really been set. You always want to put something in here so there's not garbage. You know, you don't usually, sometimes you will see people just define this constructor with the open close brace and not do anything, but what you're really doing in C++ is leaving some memory location uninitialized, and then there's garbage in it, and you don't know what that garbage is, so you don't ever want to do that. So just put some default value in, something that that probably wouldn't be a valid entry. Okay, so here's my default constructor. This constructor accepts 3 parameters, so 3 arguments will be passed if this constructor is used to create an object, and it uses those 3 values that are passed in to initialize the 3 member variables of the object being created. Okay. Again, at this point, this video does assume that you are familiar with classes and class implementation. Okay, so then here's the implementation of the 3 set methods. Of course, a set method is always a void method. In other words, it doesn't have a need to return anything. Its job is to take a piece of information and use that to initialize the member variable. So this one's used to initialize the serial number, or the item num as I called it. This one's used to initialize the name of an object, and this one's called if the price of an object has to be updated. And then again, since our 3 member variables were private, if it's needed to access them outside, if an object is being used and there's a need to access some data from within, we have our set methods. Okay? Our get methods, which basically just return the value of the private data. And a get method, of course, has a standard setup as well. The get method always has the return type, which is the same as the member variable that it is returning. So price was a double, so this one, the return type on this is double. Same idea here. Item num is an int, so the return type's an int. Same thing here. Get name is a string, so the return type's a string. These 3 are declared as const. As you might recall, your program will still, your code will still work if you don't declare your function as const. But what this allows the compiler to do, this tells the compiler that this function does not change the object. Okay, I didn't have that on any of the other functions, as you recall, because all the other functions do change the object. These two are involved when the object's being created and initialized. These 3 do change, each of them change the value of a member variable in an object. These 3 just return something. They do not change the state of the object at all. And it's pretty important, really, to put this here, because this, again, lets the compiler know that this function does not change the object. And then if another function, where it becomes really important, is if another function calls this function, and the function that calls this function is bound not to change the object, the compiler is assured that this one doesn't either. So it's pretty important. Any function within a class that you write that does not change the object, put a const on. And you'll notice that is done also on display item, because the job of the display item function is to simply print out the values of the 3 member variables, and then this does not change the object at all, so it is also a const function. And now we get down to the equal operator. This signature starts to look a little bit hairy until you get used to it, but again, if you remember what each piece means, what we have first is always your return type. If you're overloading the equal operator, well, you want to kind of overload it, so you're going to be using it to compare 2 objects of type inventory items. So if you're comparing them to see if they're equal, the result would be true or false. So the return type would be bool. The function itself is a member of the inventory item class, so it's proceeded with that. Nothing new there. There's one parameter here. It's called, I'm calling it write-op. I'll show you why in a minute. This parameter is of type inventory item. Now, write-op is an object. Typically in C++, when you pass an object as a parameter, you want to pass it by reference because it's faster. Okay, so I could have just said inventory item here, okay, and not passed it by reference, but I chose to pass it by reference because it's more efficient. But then the minute you're passing something by reference, you're making it possible for the value of the parameter to be changed and passed back to the main program. We don't want that to happen. You remember what by reference parameter passing means, right? It means any change I make to this parameter within the function affects the main, will also affect the argument that was passed to this, the value that was passed to this. We don't want that to happen, so I put a const in front of it, which means there's no change, which will guarantee there's no change to the parameter right up, but it will be passed by reference. Okay, and then we have the same const at the end. This const at the end means the same thing as it did up here, and the same thing it did up here. It means that this particular function will not change the calling object. Now, it sort of looks confusing here, like what is the calling object? Well, sometimes a way to make this a little bit simpler is to think of this function as just a regular member function. Well, it is just a regular member function, but to actually treat it and call it just as a regular member function. In other words, if A and B were both of type inventory item, I'm actually overloading this particular operator so I can do something like that, right? Where A and B are both of type inventory item. On the other hand, another way to call this function, I probably wouldn't do this, but you actually can. Another way to call this function is it's a member function, so I can call it using a object of type inventory item, and it takes one parameter of type inventory item. So I can actually call this function in this way. This is equivalent to this, okay? When I have a function called operator equal, it means I can do this, and of course I would want to do this. This is why I'm overloading the operator in the first place. But C++ would allow me to do this a different way. The name of the function is operator equal, sorry. It can be called with an object of type inventory item, and it takes one parameter of type inventory item as well. So both of these calls are equivalent, okay? So sometimes it helps, you kind of forget here when you're looking at this, which is the calling object. The left-hand operand is the calling object. The right-hand operand is the parameter object, which is why I called this particular parameter right up. Okay, so if that clarifies everything. So now, when I say if num item, well, if I'm just talking about the name of one of the member variables, I'm talking about the member variable in the calling object, namely num item is the num item field in A, right? So if num item is equal to right ops num item num, sorry, then I want to return true. In other words, I'm comparing the serial number of the two objects. Okay, and if they're equal, I'm returning true. Otherwise, I'm returning false. If you're wondering, this particular function could have been written as one line. Could have actually been written like this. This could have been the whole function, because it does the same thing, right? If this evaluates to true, I'm returning true. If this evaluates to false, I'm returning false, which is exactly what's happening up here. So, but I just wanted to kind of keep it a little clearer when we're first talking through it, so I wrote it this way. But the function could have been written, and very often you will see it, something like this written as a one-line function. And it's a little more efficient to do it that way. Okay, and then if we're overloading the equal operator, we also need to overload the is not equal operator. They're two distinct operators, so this one doesn't automatically work with two objects when you just define this one. So we have to define this one as well, and it's just going to be the opposite. If this is not equal to that, well, return true. Right? They are not equal, otherwise return false. And that is the inventory item class. And so let's make sure that compiles before we do anything else. Let's see. I didn't see that. Maybe I don't have the right window open here. Let's see. Okay, one build succeeded. Okay, so it compiled. We're all set to go. Okay. So now I'm going to add another file. I'm going to add a file that contains my application. So project, add new item, and if it contains my main program, it's going to be CPP file, and I probably want to call it, let's see, I'll just call it inventory. How's that? Okay. Now, inventory is going to use object, it's going to be doing input and output. So it's going to need to include IO stream. It's gonna, I'm going to be storing stuff in a vector. So I need to, I know I need to include the vector class. Okay, both of these files, IOStream and vector, both of these libraries have all their stuff stored in a namespace called standard. So if I want access to this, I need to say using namespace standard. Okay. I'm also going to be using inventory objects. Now, my code needs to have access to the file inventory item.h. Okay, does not need to include inventory.cpp. In fact, you don't want to do this. There's no reason to do this. Remember what's in the .h file. What's in the .h file is very simply the name of the class and the prototype for all the functions that are available for an object of that type. And that's all that the compiler needs to know to when I use the inventory item object in this particular application. Okay, and then I'm going to have a little main program. Okay, now one thing that my main program is going to do, or what this program itself is going to do, is going to allow the user to do one of four things. It's going to maintain a collection of inventory items. In other words, it's going to store a bunch of inventory items. It's going to allow the user either to add one, to print all the ones that are in the collection. So add an inventory item to the collection, print all the items in the collection, search the collection for a inventory item with a particular serial number, and search the collection for an inventory item with a particular name. Okay, so so it's going to do this over and over again until the user wants to exit. So something that I'm going to write or provide to keep some of the detail out of this program is a function. I'm going to code a function called menu. And menu is going to print out the menu and return what the user picks. So what I'm putting up here is a prototype for that function. Okay. And down here I'm going to define the function. Remember, it's always a good idea. I could have defined the function up here, but it's always a good idea to have your main up at the top so you can kind of see it and just have prototypes for anything else. Just have prototypes up here so other details won't distract you from the main. Okay, so all this menu function has to do is print out the options and return what the user selects. So I'm gonna have a variable. I'll call it pick, and this is going to be the user to store the user entry because I'm going to be prompting the user for something and asking them for it. So I need some place to put it. So now what do I want to do here? Well, again, I want to be sure and return a valid. I want to print out all the menu items. So let's see, please enter one of the following. I think I'm going to type this really. Okay. Let's see. Try to make this kind of neat here. Let's see. So if the user enters a 1, they want to add an item. If the user enters a 2, they want to print all items. And if the user enters a 3, they want to find an item by serial number. And if the user enters a 4, they want to find an item by name. And if the user enters a 5, they want to exit. Okay, so that's one big long cout statement with a bunch of end of lines in it, so we'll hopefully print a very nice version of my menu. And then I'm going to ask the user, I already asked them to enter one. When they enter it, it's going to be stored in pick. Okay, so that's cool. So that will, what I have here will present the menu and get the user's choice. Now, I kind of want to make sure that, and then the last thing this function will have to do is return the pick. Now, that's great, although if the user enters a, I forgot the 5. Okay, this is great, but if the user enters a 6, I'm returning a 6. If the user enters a 55, I'm returning a 55. I really want to make sure that this function returns a valid choice. So I'm going to put this inside of a do while. And I'm just going to kind of repeat this stuff. Repeat this while pick is less than 1 or pick is greater than 5. Okay, so while pick is invalid, I want to do this over and over again. Okay, so if the user enters anything, it's not 1, 2, 3, 4, or 5, they're going to be asked again. So by the time I get down here to return something, I'm sure it's valid. Okay? Okay, so that's the idea. So now I have a way to present the user with a menu. Okay, so what do I want to do now? Well, very simply, my program is supposed to prompt the user for a choice, carry out their choice, prompt them for another, carry it out, do this over and over again until their choice is to exit. So I'm going to declare a variable choice. And then the structure of my program is going to be like this. Choice equal, I'm going to start out by getting the user's choice, and then while, just what I just said, while choice is not equal to 5, I want to do 2 things. I want to carry out the user's choice and then get the next choice. Okay, now you can see, you can kind of conceptualize that this loop's gonna continue over and over again until the user enters a 5, or if they entered a 5 the first time, the loop won't be entered and the main will conclude. Okay, this is the structure of my whole main program. Just to make sure that this works, I'm going to put something in here that I'm going to probably delete later. This is just for testing. I'm just going to say choices. I'll put this little statement in here just so I can run this and make sure everything so far works. All this should do is keep presenting the menu until the user enters exit 5 for exit. So let's see. Pretty sure it's going to compile, so I'm just going to try to run it right away. No, it didn't compile. Okay. Silly me. Let's see. What did I do? I had a extra something somewhere. Oh, I forgot a semicolon. Silly me. Okay. Okay, so now if I say 1 is good, 3 is good, 2 is good, 4 is good, 4 is good, 4 is good, 5 exits my program. Okay, so my loop works as it should, and I don't have to worry That's the structure of my program there. I don't really have to worry, my main program, I don't have to worry about that anymore. It works just, all I have to do is replace these two statements with statements that will carry, or this particular statement with a statement which will carry out the user's choice. Okay, so how do I want to do that? I want to do that with a switch, which does whatever is needed based on the value of choice. Okay, so again, I have my loop all set up, but now instead of printing out what the user wanted, if in here, if the user said 1, I'm going to have code to add a new value to the collection. If the user said 2, I'm going to print out everything in the collection, and so on and so forth. And then, of course, after carrying out what the user wanted to do, I'm going to get a new option, and if it's not a 5, then carry out that one. So that's the structure of my code. Okay, so let's see. Before we start putting anything in here, let's remember what we're doing. We're going to have this collection, and our collection is going to store inventory items. Now, I said I was going to use a vector, so you might think that I'm going to do this. You might think that I'm going to do this, declare my vector like that. Now, I could, there's a reason for that I don't particularly want to do this because I kind of want to demonstrate how to store pointers, but I actually could do this and just keep adding a new item to the vector every single time or every single time the user chooses to do that. Okay, since this exercise is on using pointers to objects, I'm going to make my vector store pointers to inventory items as opposed to inventory items themselves. Okay, so the strategy is going to be pretty much the same. It's just that every time I put something in the vector, I'm going to put in a pointer as opposed to an object. And every time I use something from the vector, I have to remember that that is a pointer to an object, not the object itself. Okay? But wrong spot. Okay, there we go. Pointer to an inventory item, sorry. Okay, so let's see. So if the user's entered a 1, what they want to do is add an item to the collection, right? Okay, so if they're going to add an item to the collection, they have to be able to create one. Okay, basically I have to create an object and put it in the collection, or in particular, put its address in the collection, in the vector. Okay, so let's ask the user for what's the serial number. And then read in the serial number. I'm probably going to get some red squigglies because I didn't delete this. It didn't declare this variable yet. We'll go back and do it. And then I'm going to ask the user what is the name of the item. And same thing. I have to put that in a variable. And what is the price? Okay. Okay, so again, I need these to declare these 3 variables. Let me do it before I forget. So the num is a int variable, the name, a string variable. Probably, I think I want to capitalize this N there. Okay, and let's see, the price is a double. And these variables are going to be used for adding a new item. Okay, that's what these variables are for. Also, when I add a new item, I'm going to have to create a new object. And when I create a new object, I'm going to need a place to store its pointer. I don't want to, the reason I'm not going to declare anything down here because C++ gives us a hard time when we try to declare something in a switch. Okay, that's why I'm declaring these things up. So I'm going to need one more variable. I am going to be creating an inventory object, a dynamic one. So I'm going to declare a variable called item pointer as well. Again, another variable I'm going to need down here. Item pointer is a pointer to an inventory item. So they wanted to add something. I got the number, I got the name, I got the price. What do I need to do now? Now I need to create the object using that information. And if you remember, I did have a constructor that took these three things as arguments. So this creates a object. I want to create the object in real time. I want a dynamic object. So I'm going to say new. This will create the object in the heap, not the stack. And this new returns the address. The new operation does two things. It creates an object in memory, and it also returns its address, which is what I want to store in the variable item pointer. Okay. So I have the object. It's been created. I have a pointer to it stored in that variable. So what is it I wanted to do with that pointer? Oh, I wanted to put it in my list. I wanted to put it in my vector. So how do I put something in a vector? Let's see. I think I used a little L there. I think I say push back. I want to put it at the end. I started with the empty vector. I'm putting stuff in it. What do I want to put in it? I want to put item pointer in it. So I have now finished part one. I've created an object. You just said one. We've created an object and we put it in the vector. And so let's break from this case. Okay. I don't see any red squiggly lines, so it looks like there aren't any compile errors, so that's good. I could run it, but it really wouldn't. I wouldn't really be able to tell if this worked correctly until I'm able to print out all the items in the vector. So let's do case 2 right now. Okay, so case 2 will print out all the objects that have been created so far. So they're all in a vector. If I want to print out everything in a vector, the nice thing is that a vector is indexable. So I can just go through all the valid indices and access those values. And I know how many valid indexes there are by using the size. Because remember, this current size of the vector is how many things are in it. So I'm going to use this variable index and say, well, index is less than, and you've done this before with a vector a number of times. You've done this all last semester. Well, index is less than item list dot size, which is how many things are in it. I'll add one to index. Okay, so basically this will have the effect. This will have the effect of looping through. First time through index is 0, second time through it's 1, third time through it's 2, and that would be the case if size was 3, right? This will loop for 0, 1, and 2. If size was 2, this will loop for 0 and 1. So index will each time around the loop be the index of the next entity in the vector. So what did I want to do with each entity? I wanted to print it out. So let's see. So item list is my vector. I can index it with this, with index, right? So first time through, we can just think about that. First time through, index is 0. Item list at index 0 is what? What is stored in my vector? Pointers. Pointers to inventory items are in my vector. So I don't want to print out the pointer. I want to print out the object that is stored, that it's pointing to. So how do I access that? Well, I dereference. I put a star in front of that. So if item listed index is a pointer to an inventory item, star item listed index is that inventory item. Okay, so what can I do with an inventory item? I can say dot display item because I have that function. Okay. Now, I'm getting a red squiggly because there's some funny precedence with all these operators that I'm using here between the indexing and the dereferencing and so forth. When you do basically, this particular operator has a higher precedence than this one. And I really need this vector item to be dereferenced before I apply the dot to it. So I'm going to have to put parentheses around that. Okay, and so this will cause each item in that vector to be printed. And another way of writing this, a special operator that C++ created just for this, just because this parenthesis thing is kind of, people forget to do it and so forth. If something is a pointer to an object, just as item list at index is a pointer, this will call a function with the object that is being pointed to. So these two things are identical. Okay, this is just a cleaner way of writing it, if you will. But this is really showing you what's going on. This is the item in my vector. I'm dereferencing it. Then to get the object that I'm calling the function with it, this does the same thing. Okay, and that's all we need for part 2. And now we should be able to run this. I'm going to try to compile it first. Okay, my build succeeded. Good. Now let's run it. So we should be able to, at this point, we should be able to put some stuff on the list and then print the whole list. Okay, so add an item. 1. Let's see. What's my serial number? 111. Oh, what's the name? 1111. What's the price? 11. Just so I can remember what these things are. Let's see. Let's add another item. What's its serial number? 333. Let's see. What's its name? 1, 2. Okay, and what's the price? 3. And we'll add one more. Let's see. 555. 555 is the name. Because it's just a string, I can type whatever I want. The price is 5. Okay, so I should, when I do print out my list, I should see my item 1, my item 3, and my item 5. So now I'm going to give the choice, pick that choice 2 to print all items. I do see, I could use some spacing, I think, here, but I see here's my first item, here's my second item, here's my third item. Okay, and when I click select 5 to exit, my program exits. So everything works so far. Actually, you know what? So what I'm going to do after I display an item, I'm actually going to do a blank line, just so my output's nicer on that, so it doesn't all squish together like we saw. Okay, so now we're halfway done, or even more than halfway done, because options 3 and 4 are pretty close together, are pretty similar. Okay, so let's see. Case 3. Let's see, case 3. This one we want to search for an item by serial number. Now there are a couple different ways that I can do that. Since I'm basically going to have to look through every item in the vector to see if there's one whose serial number matches a serial number that's given by the user. Now one way to do it would be to look at each item one at a time and call upon getNum, my getNum function, and to see if the number inside the object is what I'm looking for. Now that's fine, and that might be the way I'd want to do it, but I really want to make a point of checking out my equal function. So I'm going to do this a different way. I'm actually going to do this, write a solution that uses the overload here because we wrote it. Okay. Okay, so I am going to have to first ask the user what serial number what are they looking for, and read that in. I can reuse this variable that I declared before. Oops. Let's see. Cin has input. Input stream time. I have to use the extraction operator. The extraction operator. Okay, so here we go. So I know what the number is now. I'm going to declare an object up here just for this purpose. I'm going to declare an object called dummy object. Okay, now you know when I do this, I've just created a object of type inventory item using the default constructor. So dummy object is a object of type inventory item. I'm going to take my dummy object and I'm going to set its number field to the number that we're searching for. Okay? So I have an object whose number field is the, if the user wanted to see it, find something with the serial number 5, this dummy object's item number is 5. Now, since I am doing a search and I want to know if I found something, I'm going to declare a little, I don't think I can declare this. Well, I'm going to put it up here anyway because I'm going to use it in a couple places. I'm going to have this variable called found that I'm going to use in a couple places whenever I do a search. It's going to be a variable to indicate if the search is successful. I'm going to have a Boolean variable with a false in it. So I have this variable found, and it has a false in it. I better just double check that it has a false in it by putting one in. And so now I can basically go through and say, let's see, while, do I want to use a for or a while? Let's see. I'll use a for because I have to index. So I'll use a for. I'm gonna go. We're gonna use that same loop we did before. We're gonna look through each element of item list. And we're going to say if, okay, if, well, item list at index is what? Oops. Item list at index is a pointer to a inventory item, right? So star item list at index is an inventory item. So if the current inventory item is equal to dummy obj, in other words, the item that I put the number in, then what? Well, then I want to print it out. I'll use the shortcut way that we saw before. Matter of fact, I want to do two things. I want to print it out if they're equal. In other words, because remember that equal operator is based only on that one field. The two items are equal if they're but their serial numbers are the same. So if those two are equal, I want to print it out, and I also want to set found to true, so that when I'm done looping through all these items, so I'm going to loop through all these items. Anytime there's one that's where they're equal, it's going to print it out and set found to true. There should only be one case where that would happen if it's there, because serial numbers are unique. But the idea is that when I'm done with this for loop, if found is equal to false, I know that this never happened. I know that I never found something with that serial number. So if found equals false, I could print there with no matching serial number. Okay. So here, when I'm looping through it, if I found it, I printed it. If I went all the way through and didn't print anything, when I get down here, I can identify that I didn't find it, and print out an error message. And that's all we need to do for part 3. Okay, and again, this is still in our switch, so this is all of part 3 to do the search. Up here again, we're a loop. Up here, what did we do? We loop, looking at each one. That's what we did. Okay, so let's see if this works. So now we should be able to type in a 1, 2, or a 3. Okay, so great. So 1, let's just put some stuff in. Whoops, I typed in a letter instead of 1, 2, 3, 4, or 5. Sorry. We need exception handling to fix that, and we don't have that in right now. So 1, 1, 1, 1, 1, 1, 1, 2, 2, 2, 2, 2, 2, 1, 4, 4, 4, 4, 4. So I remember what I did here. 4, 4. Okay, I'm going to print everything, so I have see what I have. So the objects I have are serial numbers 1, 1, 1, 2, 2, 2, and 4, 4. Okay, so let's try to search for something. So first, let's see, 3. What serial number? I'm looking for 7, 7. 7, 7. It tells me there's nothing matching that serial number. Okay, great. There shouldn't be. This is 3, and let's try 2, 2, 2. I do have a 2, 2, 2. And when I type in 2, 2, 2, it prints out my object. I probably should have a space before I start my please enter prompt again. A blank line there. But anyway, it appears that my search works. I'm going to type a 5 to exit. And now, the 4 is going to be very, very easy. Actually, while I'm thinking of it, let's go right down here to this menu and just start off with a \n, which will give us a blank line, make the output a little bit neater. Okay, so 4 is going to be easy. Matter of fact, you know how I'm going to do 4? I'm going to cut and paste 3. So cutting and pasting isn't always the best idea unless you know what you're doing, but I think we can easily do the. We're pasting, but we have to edit this. Okay, here. What are we doing in case 4? Searching by name. So let's look at each line and see what's going on. What serial number are you looking for? Well, we don't want a serial number here. We want a name. And so we need a string variable here to read it into. So we'll say the name. And now instead of setting in our, well, I'm not even going to use the dummy object in this. I'm going to use the get functions to make this a little bit easier for us. So I'm not going to use the dummy object. So we have the name, and we're going to loop and search for it. So since we're going to loop through and look for every object in the vector with this particular name, I'm going to start out assuming I haven't found it. I'm going to use the same loop through each one. And for each one, well, instead of saying if item listed index is equal to dummy object, I'm not using dummy object anymore. I didn't set that up. Again, I just want to know if the name inside of the object that item at index is pointing to is equal to the name. So I can just say item list at index. Okay. If item list at index if the name of the item, if the name inside of the object is equal to the name, here I am, I'm comparing two strings here. I'm comparing the let me see. Let me think on this for a minute. I'm comparing the name inside of the object. I'm calling getName. And I'm comparing that to the name that I just read in. And if they are equal, then I'm displaying the item and setting found to true. Although if I go through them all and that hasn't happened, I'm printing out there is no matching name. Okay, so we could have done case 3 in the same way and used get item number instead of creating that dummy object. I just wanted to test that equal operator that was defined in the class and just show you how that could be used. Okay, so we got a name, looping through them all, and for each item with each item in the list, with each object in the list, we're dereferencing it. You know, because remember this little arrow thing's the same as having dereference dot. Dereferencing it, calling getName, and if that is equal to the name we're looking at, we're printing. Otherwise, an error message. So let's see if everything works. Okay, so add an item. My serial number is 1. The name of the item is 1. What's the price? 11. I'm going to add another one. 2, 2, 2, and let's see, one more. 4, 4, 4, 4. Okay, I'm going to print them all. So you can see this is the first object that's stored. This is the second one. Here's the third one. And we already know that 3 works. We already tried that. So let's try 4. Check for something by name. If I'm looking for something by the name Sam, I see no, there's nothing matching that. If I do 4 again and look for something with the name 2, yes, I do see that object. So a little bit more testing would be warranted, but I'm pretty confident that this is all working. I'm going to click 5 to exit. And that is your array of objects, your storage for output, and searching through array of objects a couple different ways.